Hello, and welcome to my video on word problems. In this video, we're going to work with what you've learned so far with logarithms and apply it to other problems that you see earlier in the exponential functions unit. So if we take a look at the first example here, we see that Matthew received $3,000 for his high school graduation. He decides to invest this money in a bank account that earns 2.3% compounded monthly. And we have to determine algebraically how long it will take for Matthew to double his money to the nearest tenth of a year. So if you notice, he's invested money in an account that's going to earn its interest compounded monthly. And so we're going to apply that formula that we work with early in the year, or in the early in exponential unit of the compound interest formula. So this is that formula. And so now we'll start just plugging in what we're given the problem. So the $3,000 is the amount of money that he invests in the bank account, and that's going to be our p-value, our principal. The interest rate is 2.3%, so that's our r value. And so we'll convert that into decimal form and plug that in for r. N is the number of times that interest is compounded during the year. So if it's compounded monthly, our interest, that's 12 times during a year. So plug 12 in for N. And T is the time in years that the money is invested for. And that's what we're being asked to solve for. We're being asked to determine how long it takes for Matthew to double his money. So I'll put in X for T. And A of T is the amount of money that we have in the bank account after a certain number of time. Since we have to determine how long it takes for Matthew to double his money, we can write 6,000 over here, A of T, because that is twice the amount of 3,000. So now we're going to solve for the X in this equation, which, if you notice, is in over here as the exponent. So as we've done in the logs unit, if we want to solve for the X, we'll want to get this base and this exponent by itself. So we can do that by dividing both sides first by 3,000. And so we'll get on the left side the value of 2. And on the right side, I'm going to do the operation of 1 plus 0.023 over 12, calculate what that's equal to on my calculator, and that should give us 1.001916667, and that is still raised to the 12x. Now that our base and exponent are by themselves, we can take the natural log of both sides, and doing this allows us to take this 12x and bring it down in front of our natural log. And then, as we've done with other problems, if we want to get just x all by itself, we have to get rid of this 12 and this natural log, which are being multiplied to our x. So in one fell swoop, we can divide both sides by that 12 natural log of this entire expression. And when you do this, I would, on this left-hand side, I would punch that all into my calculator at once and round it to the nearest tens place. You should get 30.2. Okay, now for the second problem on the worksheet. This is going to be similar to the first problem. In this question, we see that Mary places $8,000 in an investment account with interest compounded continuously. And in this example, we have to determine algebraically the annual rate needed for the account to grow to $11,460 after 20 years. And we're going to round our answer to the nearest tenth of a percent. So because Mary is invested in an account that compounds interest continuously, we're going to use that formula, which, if you recall, again, was our PERT formula. And we can start by just plugging in the values that we know from that are given the problem. So remember, P is the initial investment, and that is the $8,000. E is our special number, just like pi, very, very special. R is the interest rate, and that's what we're actually being asked to solve for. We have to find the annual rate. So I'll plug in X for R, and T is the time in years, and in this case, that is 20. And A of T, again, is how much money we have after a certain amount of time, and this problem, that's the $11,460. So once again, here's our equation. We want to solve for x, which is in the exponent. And so like the last question, since x is in the exponent, we're going to want to get this base of e raised to the exponent of x times 20 by itself. So we can do so by dividing both sides, initially by 8,000. So on the right side, we'll get e to this x times 20, and since multiplication is commutative, I'm just going to write that instead as 20 times x. And on the left-hand side, we can input that into our calculator, and I'm going to leave the answer that I get on my calculator as a fraction in simplified form, which should be 573 over 400. Now, once again, since our base and exponent are by themselves on the right side, we can take the natural log of both sides. And this allows us, in particular, on the right-hand side there, to bring that exponent of 20x to go down in front of our natural log. And to solve for the x, we can divide both sides by the 20 natural log of e. And again, on that left-hand side, all this information there, I would punch that into my calculator very carefully all at once and get 0.017971. And when we convert this to a percent, to the nearest tenth of a percent, we're going to get that x should equal 1.8%. So hopefully this video helps you out with solving for these types of problems. Both these questions were using the compound interest formula or the PERT formula that we saw early in the year, but this time now we're solving for the variable x and the exponent. So hopefully this will help you answer the questions that are on the homework sheet. Thank you for watching, and take care.